Have you ever been at a party, like, surrounded by people, maybe laughing, the music is playing, the conversation is flowing?
Right, just a totally normal Friday night.
Yeah, exactly. And then completely out of nowhere, you feel this overwhelming, just freezing sense of isolation.
Oh, wow.
Yeah.
That is a very specific, very visceral sensation.
Right. It's like the noise of the room just sort of muffles, and it's like you're suddenly standing behind a pane of like thick soundproof glass.
You're physically right there in the center of
Yeah.
the crowd, but psychologically, it's like you're watching everyone else exist from a million miles away.
Yes, exactly. And today we are taking a deep dive into that exact phenomenon to really understand the biological machinery driving it.
Because it turns out, that freezing sensation isn't just you being moody,
No, not at all.
and it's certainly not a character flaw. It's actually a profound neurobiological event.
And to unpack this, we're going to look at a really comprehensive psychological and neurobiological analysis of a single, highly detailed nightmare.
Yeah, this one dream is basically a Rosetta Stone for understanding sleep physiology, evolutionary biology, and really the literal neuroscience of social rejection.
So our mission today is to decode what our brains are actually doing when a fun, everyday social interaction suddenly morphs into this suffocating nightmare.
We're bypassing the mystical, crystal ball interpretations of dreaming here.
Right. No dream dictionaries today.
Exactly. We're looking at the hard science of what the brain is doing when it perceives a threat, how it actively tries to keep us alive.
And we're going to uncover what this teaches us about the physiological reality of the introvert hangover, like why social pain registers in the brain exactly like a physical injury.
Yeah, it's the part that is just wild to me. The brain is so literal regarding social dynamics.
Like when we use metaphors, right? A broken heart or being stabbed in the back.
Yeah, or a punch in the gut. The fascinating and honestly somewhat terrifying reality is that to your neurological hardware, those aren't metaphors at all.
They're literal.
The brain processes them as literal physical trauma.
Okay, so before we get into the heavy neuroscience, we need to lay out the dream itself because it serves as the foundation for this whole deep dive.
It really reads like a gripping psychological thriller.
It really does. So let's start with the setup, which is rooted in absolute comfort. The dreamer begins in a familiar setting in Japan. They're just hanging out, playing games with a close-knit group of friends.
It's warm, it's safe.
Deeply familiar, but then seamlessly the environment just dramatically expands.
Which is a classic feature of REM sleep architecture, by the way.
Right, that sudden shift. So the dreamer is suddenly transported from this small, intimate room to a massive, glamorous ocean-crossing cruise ship.
The social circle just expands exponentially.
Yeah, they aren't just with local friends anymore. Now they are working and socializing alongside this dynamic, international, global team.
And the auditory and visual processing in the dream state kicks into overdrive here.
Oh, yeah, there are cheers echoing around the deck, the splashing of pool water, people clinking glasses.
The entire atmosphere is just vibrating with high achievement, pure belonging, and total integration into a powerful, larger-than-life group.
So, in psychological terms, this is like the absolute pinnacle of social security.
The nervous system is completely relaxed. The social reward pathways are flooded with dopamine.
The dreamer feels completely secure in their status, like they belong.
But then we hit the pivot.
And the pivot is incredibly subtle. It's not a monster appearing on the deck. It's a micro rejection.
A tiny social paper cut.
Exactly. So the dreamer decides to visit a friend's room on the ship. When they walk in, there's an international couple hanging out. The environment is casual, and everyone in the room is smoking.
Right.
So the dreamer, wanting to, participate in this shared ritual, asks for a single cigarette. Just one. And they are denied.
Everyone else is smoking, everyone else is partaking in the bonding activity, but a boundary is suddenly drawn right in front of the dreamer.
They are explicitly told no.
Yeah.
Now, in the waking world, this is the kind of interaction you just brush off.
Yeah. You laugh awkwardly, say no worries, and move on.
But in the dream, this tiny denial acts as a catalyst for a total psychological collapse. It fundamentally shifts the dreamer's entire reality.
Because to the conscious waking mind, a denied cigarette is a minor awkwardness.
Yeah.
But to the deep, ancient subcortical regions of the brain,
It's an alarm bell.
it is a massive alarm bell. It instantly signals that your status in the group is conditional. You have been placed on the outside of the circle.
And for a social primate, being On the outside of the circle historically means you are going to die.
Right. You don't survive alone in the wild.
So you can actually see the dreamer trying to fight that ancient alarm bell through compensation in the dream.
Oh, the overcompensation is intense.
Right. Instead of absorbing the discomfort, the dreamer loudly announces to the room, "I'm going home," and then proceeds to run all around this massive cruise ship,
Going from deck to deck.
delivering these incredibly energetic, loud goodbyes to everyone they pass. And for a brief moment, it actually seems to work. People wave back saying, "Great job," and "See you later." The dreamer experiences this rushing wave of warmth and accomplishment.
Because they are flooding their system with outward energy to overwrite the feeling of rejection.
It's a
A
performance.
highly demanding performance of sociability. They are attempting to artificially generate the feeling of belonging that was just ruptured.
But the performance burns through their remaining cognitive resources, and immediately after the grand exit, the descent begins.
The physical environment of the dream radically alters here.
Yeah, that bright, sunlit, splashing pool area vanishes. The dreamer suddenly finds themselves in a dim, slimy, claustrophobic corridor deep in the bowels of the ship. The air gets heavy.
And that's when the pursuers appear.
Yes, and it's not a wild animal chasing them. It's two very specific, unsettling human figures. A man in a sharp suit who is aggressively trying to sell the dreamer drugs, and a doctor in a white coat who is relentlessly trying to inject the dreamer with a strange yellow liquid.
These are highly symbolic figures, right? Authority, intervention, forced modification.
It's terrifying. So the dreamer starts fleeing. They hurl themselves down a water slide to escape, spiraling further down into the darkness of the ship. But the pursuers are relentless.
They never lose pace.
No matter how fast or far the dreamer slides, the man in the suit and the doctor maintain pace, always right behind them. Finally, driven by pure, exhausted desperation, the dreamer finds a dark room to hide in.
And this is where it gets really dark.
Literally and figuratively. They scramble inside and pull themselves into a drawer, but as their eyes adjust to the dark, they realize it's not a normal drawer. It's a drawer in a morgue.
Wow.
And surrounding them, in the other open drawers, are the dead bodies of the very friends and the international team they were just celebrating with up by the pool.
The entire social network is dead, cold, and stored away. It is a profound visualization of total relational collapse.
The brain is basically manifesting the absolute end of social connection, which leads to the climax. Out of the darkness, one of the dead people reaches out and violently tears off the dreamer's hand at the wrist.
But, and this is a critical detail, there is absolutely no physical pain.
Right. The dreamer registers no physical sensation of the dismemberment. There is only pure, paralyzing existential terror. And that's the moment they wake up, heart pounding, completely drenched in sweat.
You know, this narrative perfectly mirrors the physiological trajectory of real-life emotional crash.
How so?
Well, we frequently use up all of our outward conscious energy to maintain a smiling facade in a complex social setting, desperately proving that we belong.
Right.
The moment we are alone, the moment the performance stops, all that suppressed anxiety, the exhaustion, the fear of not truly fitting in it, violently bubbles to the surface.
So the brain just condenses an hours-long emotional hangover into a highly concentrated, terrifying cinematic sequence.
Exactly.
Which really forces us to ask the fundamental biological question, why? Like, why does the brain do this? Sleep is supposed to be restorative. We are supposed to be resting.
Right, repairing the body.
So why would the brain manufacture such a horrifying, exhausting sequence of events that leaves you waking up in a cold sweat with a spiked heart rate?
To understand that, we need to look at how our understanding of sleep physiology has evolved, because for a long time, the dominant scientific consensus was heavily influenced by the activation synthesis hypothesis.
Right, that was proposed by Hobson and McCarley back in the 70s, wasn't it?
Yes, the 1970s. And the activation synthesis hypothesis essentially argued that dreams are a biological accident.
An accident.
Yeah, the theory states that during REM sleep, the brainstem fires off spontaneous random electrical pulses. These are known as PGO waves.
PGO, what does that stand for?
It stands for pontogeniculo-occipital waves.
Okay, that's a mouthful.
It is. Basically, these waves originate in the pons, which is a structure in the brainstem. Then they travel up through the lateral geniculate nucleus, which usually processes visual info when we're awake. And finally, they splash into the occipital cortex at the back of the brain.
So it's literally just neurological static shooting through the visual processing center.
Precisely. It is random physiological noise. But the cerebral cortex, the highly evolved logical storytelling part of our brain, It hates randomness.
It constantly seeks patterns.
Exactly. So when it receives this barrage of random static, it frantically tries to make sense of it by stitching together whatever memories, images, or residual emotions happen to be lying around.
Okay, but under this framework, the dream itself has no inherent meaning.
Right, no purpose. It is merely the cortex's desperate attempt to impose a narrative structure on random neurological firing.
But looking at the dream we just analyzed, the activation synthesis hypothesis feels deeply inadequate.
Oh, completely.
Because if a dream is just the brain trying to organize random static, how does it construct such a perfectly paced, emotionally devastating, symbolically rich narrative?
It doesn't really add up.
Right. The progression from the micro-rejection to the frantic overcompensation down into the dark corridor, ending in the morgue that isn't random noise. That is a masterclass in psychological storytelling that perfectly tracks with a decaying emotional state.
And that inadequacy is exactly what led to a major paradigm shift in evolutionary psychology and sleep science.
Enter Antti-Revonsuo.
Yes. Revonsuo introduced a much more robust framework known as the threat simulation theory, or TST.
And what does TST argue?
He argued that dreams are far from random. They are a highly specialized, genetically hardwired evolutionary adaptation. The human brain evolved to simulate ancestral threats during sleep.
Ancestral threats, like the kinds of threats that dictated the survival of early hominids.
Exactly. Being chased by predators, navigating hostile terrain, defending against attacks.
So the brain is essentially running a highly immersive virtual reality training program while the body is safely asleep.
Yes, so we can rehearse our avoidance and survival behaviors. By practicing running from a predator in your dreams, the neural pathways governing escape behaviors are strengthened.
That way, if you encounter a predator in waking life, your reflexes are already primed and optimized.
The evolutionary math is totally sound. The hominids who ran these nightly threat simulations had a slightly higher probability of surviving a real-life attack the next day.
Which means they were more likely to pass on the genes that coded for this dream simulation mechanism.
Over hundreds of thousands of years, this system became deeply embedded in human neurobiology.
Okay, but in our dream, the dreamer wasn't running from a saber-toothed tiger. They started out on a luxury cruise ship playing games. Where is the threat simulation in a pool party?
Well, that brings in Revonsuo's complementary framework, the social simulation theory, or SST.
Okay.
You have to remember, human beings are apex predators, not because of our sharp teeth or fast legs.
Right, we're pretty squishy.
Very squishy. We survive because of our ability to cooperate. For our ancestors, survival depended entirely on the ability to maintain complex social bonds.
If you were exiled from the tribe, you lost access to shared food, fire, protection.
You would almost certainly die. Therefore, the brain doesn't just need to simulate physical threats. It needs to simulate social dynamics.
Oh, I see.
It practices bonding, navigating hierarchies, maintaining group status. The beginning of the dream, the games in Japan, the global team on the cruise ship. That is the brain running a highly successful social simulation.
It is actively practicing belonging.
Yes.
This makes the pivot point in the dream so much more profound. When the friend denies the dreamer the cigarette, it's not just a social faux pas. It is the exact moment the brain's cognitive load exceeds its capacity and the entire simulation parameters change.
The brain perceives that micro-rejection as a direct threat of social exclusion. Because exclusion historically meant death, the brain violently shifts gears.
In a fraction of a second.
Yes. It aborts the social simulation program because the bonding attempt has failed, and it hits the emergency override to activate the threat simulation program.
It switches from practicing belonging to practicing surviving a lethal threat.
That is the exact mechanism driving the visual shift in the dream. The bright pool disappears, and the dark, slimy corridor materializes because the brain has literally changed its operating system from connection to survival.
Wow. The environment of the dream is just a visual manifestation of which evolutionary software program the brain is currently running.
Exactly.
And this also explains the terrifying physical sensations of the chase itself. Like, we've all had that dream where you are trying to run away from something horrifying, but your legs feel like they weigh 1,000 pounds.
Or you feel like you're trying to sprint through molasses.
Yeah. In this dream, the person throws themselves down a water slide, but can't seem to generate any distance from the pursuers. Why does that happen?
Well, the sensation of being unable to run is a fascinating collision of the mental simulation and the physical reality of your sleeping body. It involves a biological mechanism called the tonic immobility reflex.
Tonic immobility.
Right. When we enter REM sleep, our brain actively paralyzes our major voluntary muscles.
Paralyzes them completely.
Yeah, it's a chemical process.
Yeah.
The brainstem releases neurotransmitters like glycine and GABA down the spinal cord to inhibit the motor neurons.
Okay, but why?
It is a brilliant, necessary safety feature. If your brain is running a highly realistic simulation of fighting off a predator, you do not want to actually start punching, kicking, and running around your bedroom.
Right, without this paralysis, we would constantly injure ourselves in our sleep.
So every time we hit REM sleep, we are chemically locked in place.
So the nightmare gets its unique texture of terror when the brain attempts to reconcile two conflicting streams of data.
Exactly. On one hand, the amygdala and the visual cortex are running a threat simulation that demands immediate physical action. Run away from the men chasing you.
The brain sends the signal to sprint.
On the other hand, the brain is receiving sensory feedback from the actual physical body lying in the bed, which is chemically paralyzed and cannot move.
So the brain is screaming, "Go!" while the body is reporting back, "I literally cannot move."
The brain has to synthesize these conflicting inputs. The resulting conscious experience within the dream state is the suffocating, terrifying sensation of intense effort yielding zero movement.
The mental urgency of the threat simulation merges with the physical reality of tonic immobility.
Creating the classic nightmare sensation of being physically restrained, weighed down, or moving in agonizing slow motion.
Okay, the mechanics of how the brain builds the nightmare are incredible, but it leaves us with a glaring disproportion here.
What do you mean?
Well, why does a social awkwardness being told you can't have a cigarette trigger a survival-level threat simulation in the first place? It seems like a massive overreaction, honestly.
It does seem like that.
Why does the brain treat a minor social slight with the same physiological urgency as a literal physical attack?
This is perhaps the most profound neurobiological revelation we are unpacking today. It takes us deep into the anatomy of social pain. The simple, shocking answer is that, to the brain, there is no structural difference between a broken heart and a broken bone.
Wait, no structural difference? I really want to emphasize this because it challenges everything we are taught about emotional resilience.
Right, we treat emotional pain as something abstract.
Something you should be able to just get over or think your way out of. But neurobiology says that social rejection and physical trauma utilize the exact same neural circuits in the human brain.
Yes, it is a matter of anatomical efficiency. Evolution didn't build a separate alarm system for social pain. It simply co-opted the existing physical pain network.
How does that network work?
Well, it heavily involves a region called the dorsal anterior cingulate cortex, or the DACC.
The DACC.
You can think of the DACC as the brain's primary alarm system for anything that threatens our well-being. Historically, neuroscientists believe the DACC solely processed physical tissue damage.
Like getting cut or burned.
Exactly. But functional MRI studies have repeatedly shown that the DACC lights up identically when we experience social conflict, exclusion, or rejection.
It is the siren that screams, "Something is damaging us, pay attention."
Yes.
But the DACC is just the alarm. A siren itself doesn't hurt. The actual sensation of pain is generated elsewhere, right?
Correct. The DACC sounds the alarm, but that signal is transmitted to the anterior insula, or the AI.
Okay, what does the AI do?
The anterior insula is responsible for translating the alarm into a subjective conscious experience. It gives the pain its specific flavor.
Flavor.
Yeah, so when you burn your hand on a stove, the AI translates the nerve signals into a sharp, searing sensation.
Okay, that makes sense.
But when you get socially rejected, when you are denied that cigarette in a room full of peers, or when you aren't invited to the party, the AI translates the DACC alarm into that sickening, heavy feeling in your chest.
Oh, wow. It generates the subjective feeling of a broken heart or that suffocating tightness in your throat.
So when someone says a rejection physically hurts, they aren't being dramatic. Their anterior insula is literally manufacturing a somatic pain response.
It is entirely literal.
It is. And the neurology gets even more intense when we look at chronic or severe social pain.
Like if the exclusion isn't just a passing awkwardness.
Right. If it's something sustained, like prolonged bullying, a devastating romantic betrayal, or deep, persistent loneliness, the pain processing moves even deeper into the brain's physical trauma networks.
Where does it go?
It begins to heavily activate the secondary somatosensory cortex, known as S2, and the posterior insula.
And those areas are specifically dedicated to severe physical trauma.
Exactly. The secondary somatosensory cortex maps the physical topology of your body. If you shatter your femur, S2 processes the exact location and intensity of the shattered bone and the torn tissue.
So when functional neuroimaging shows S2 and the posterior insula lighting up due to severe social exclusion.
It means the brain is no longer just processing an emotional ache. It is processing the social isolation as literal, agonizing physical tissue damage.
That is horrifying.
The brain is frantically searching the body for a massive bleeding wound because the neurological signals are identical.
Meaning someone experiencing profound chronic loneliness is, from a neurobiological standpoint, enduring a state of constant physical trauma.
Yes. This shared circuitry is a deeply ingrained mammalian mechanism. We can see this clearly in animal models, actually.
Like how?
If you separate a young mammal, a puppy, a primate, a guinea pig, from its mother or its social group, it will immediately begin to emit distress vocalizations. It cries out.
Which is a vital survival mechanism designed to call the caregiver or the pack back to the isolated animal.
Right. However, if researchers surgically lesion or deactivate the anterior cingulate cortex, that DACC alarm we just discussed, the animal will completely stop emitting distress cries when separated.
Wait, really? Without the DACC to process the pain of the separation, the animal simply doesn't register that being alone is a problem.
The isolation no longer registers as painful.
Which might sound like a peaceful state, but in the reality of the wild.
An infant animal that doesn't cry out when separated from its mother is an animal that will quickly freeze to death, starve, or be eaten by a predator.
Wow, so the social pain network is an essential evolutionary survival mechanism.
The intense burning pain of loneliness is the biological motivator that forces us to seek the safety of the tribe.
And there is a genetic component to this too, isn't there? Not everyone's alarm system is calibrated to the exact same volume.
Oh, absolutely. The OPRM1 gene mutation provides incredible insight into this.
The OPRM1 gene, break that down for me.
So the OPRM1 gene codes for the mu-opioid receptor, which is a critical part of the brain's endogenous opioid system.
Endogenous meaning the painkillers our bodies produce naturally.
Yes, exactly. And this system regulates both pain relief and the sensation of social reward. Research has demonstrated that individuals carrying a specific variation of this gene, known as the G allele, are significantly more sensitive to physical pain.
So they naturally have a lower pain tolerance.
Right. But crucially, because the neural circuits are shared, these individuals are also hyperreactive to social rejection.
Oh man. So if your genetics dictate that you feel a physical scrape more intensely than the average person, those exact same genetics dictate that you will feel the pain of a social slight more intensely.
Your DACC and anterior insula are simply wired to react more aggressively to any perceived threat.
Which really brings us to the actual lethality of this biological response. When the brain interprets social isolation as a physical threat, it triggers a cascade of physiological defenses that, over time, degrade the body.
Julianne Holt-Lundstad and Tim Smith conducted massive meta-analyses on the health impacts of chronic loneliness.
Right.
They analyzed data from hundreds of thousands of individuals looking at all-cause mortality. The results were staggering. They found that chronic subjective loneliness carries an early mortality risk equivalent to smoking 15 cigarettes a day.
Smoking 15 cigarettes a day. That is, we have massive public health infrastructure dedicated to smoking cessation. Yet loneliness is silently exerting the exact same toll on human mortality.
The mortality risk of chronic loneliness actually far surpasses the health risks associated with obesity, physical inactivity, or air pollution.
And the mechanism driving this mortality is clear, right? When the brain constantly perceives the threat of isolation, it keeps the sympathetic nervous system, the fight-or-flight response, locked in the active position.
Yes, the body is constantly bracing for an attack that never comes physically, but is constantly felt socially.
And this chronic sympathetic arousal leads to a persistent flood of cortisol and other stress hormones.
It causes systemic inflammation, elevates blood pressure, accelerates arterial aging, and significantly suppresses the immune system. We see a persistent upregulation of pro-inflammatory genes and a downregulation of antiviral responses.
The body is essentially burning itself out, degrading its own cardiovascular and immune architecture, trying to survive a nonstop biological emergency.
To synthesize this, the brain isn't overreacting in the nightmare.
No. When the dreamer is denied the cigarette, the brain knows that isolation is biologically lethal. It is treating the social exclusion with the exact same physiological urgency as a predator attack.
Because, evolutionarily, being kicked out of the tribe meant certain death. The nightmare is actually a proportionate response to what the deep brain perceives as a lethal threat.
It is the brain desperately trying to save your life by terrifying you into maintaining your social bonds at all costs.
Absolutely.
But this raises a crucial point about individual differences. If we all share this neurobiology, if every human has a DACC and an anterior insula, why do some people experience these intense hypervigilant states constantly, while others seem completely unfazed by social friction?
Like, why did this specific dreamer's brain snap into a full threat simulation over a casual cigarette refusal, while someone else might have just shrugged and enjoyed the rest of the party? That brings us to the intersection of neurodiversity, sensory processing, and what is commonly referred to as the introvert hangover. The reality is that human nervous systems do not all process social data the same way. A key concept here is rejection-sensitive dysphoria, or RSD.
Rejection-sensitive dysphoria. It sounds like an extreme version of normal social anxiety, but the mechanics are much more specific, right?
Very specific. While RSD is not currently a standalone diagnosis in the DSM, it is a highly recognized, profoundly debilitating clinical phenomenon. It's particularly prevalent among individuals with ADHD, autism spectrum disorder, and those who identify as highly sensitive persons.
Okay, so how does it differ from just being nervous about rejection?
Well, normal fear of rejection makes you cautious. You might hesitate to ask for a promotion or feel nervous before a first date. But for someone experiencing RSD, a microscopic a delayed text message, a slightly flat tone of voice, or a casual refusal of a cigarette is processed by the brain as an immediate catastrophic survival threat.
The DACC alarm isn't just ringing, it's stuck on maximum volume and the off switch is broken.
Exactly. And in the context of ADHD, there's a fascinating mechanical reason for this intense reaction, heavily tied to working memory deficits.
Working memory. When we talk about working memory, we usually think of it as the ability to hold a string of numbers in your head for a few seconds. How does that apply to emotional regulation?
Working memory in the prefrontal cortex acts as a crucial emotional buffer. It allows you to hold context in your mind while you process a new piece of information.
Oh, I see.
If someone without RSD experiences a friend acting irritable, their working memory quickly pulls up the contextual data. We've been close friends for 10 years, they just lost their job, they're having a bad day, this isn't about me.
The context regulates the amygdala's fear response.
Right. It provides a buffer of social object permanence. You remember that you are fundamentally loved and safe, even in a moment of friction.
But individuals with ADHD often have profound deficits in working memory.
Yes. So in a moment of stress or perceived rejection, that contextual data is simply not available to them. They suffer from a deficit regarding past social successes. In the absence of that comforting context, the brain immediately defaults to the most ancient primal assumption. They are rejecting me. I'm being exiled from the group. I'm in lethal danger.
The cognitive exhaustion of that must be immense. You would constantly fall into imposter syndrome, perpetually scanning the room for micro-rejections.
Desperately trying to prove that you aren't about to be kicked out of the tribe. It requires a staggering amount of metabolic energy to constantly analyze every facial expression, tone of voice, and body language cue for signs of danger.
Which leads directly into the neurology of the introvert hangover.
Yes, the P scans.
Right. The research utilizing PET scans positron emission tomography has physically mapped why socializing is so uniquely draining for certain nervous systems. And this research by Johnson and her team looking at brain blood flow is incredibly validating for anyone who has ever felt physically ill after a long networking event.
It really is.
What did the PE scans reveal about the hardware differences between introverts and extroverts?
When you look at the brain blood flow of introverts and highly sensitive people compared to extroverts, the contrast is stark. In introverted brains, the resting state shows consistently high blood flow to the frontal lobes and the anterior thalamus.
These are the regions responsible for complex internal processing, right? Planning, problem solving, deep introspection, analyzing the past, predicting the future.
Yes. The introvert's brain is naturally buzzing with a high level of complex internal cognitive activity, even when they are sitting entirely alone in a silent room. Their baseline of cortical arousal is already very high.
So they're just sitting there, but their brain is basically running a marathon.
Exactly. Now contrast this with extroverts. Extrovert brains tend to show higher blood flow in areas related to sensory processing and the dopamine reward pathways.
Okay, so dopamine is the key here.
Right. Extroverts generally have a lower sensitivity to dopamine, meaning they require high-intensity external stimuli to release enough dopamine to feel energized and satisfied.
Novel experiences, talking to large groups of people, loud, dynamic environments.
Exactly. The extrovert goes to the loud party, gets a massive rush of dopamine from the crowd, and their nervous system feels perfectly stimulated and rewarded.
But what happens when the introvert, whose brain is already highly active internally, walks into that same loud party?
Introverts are hypersensitive to dopamine. They need very little of it to feel stimulated. So when they enter a highly complex, loud social environment, they are instantly hit with a dopamine overflow.
It is far too much stimulation layered on top of an already highly active frontal lobe.
Their nervous system rapidly becomes overstimulated and overwhelmed.
So, to use a mechanical metaphor, extroverts operate like solar panels. They literally charge their batteries by being out in the sun, absorbing the bright, loud energy of socializing.
I like that analogy.
But introverts and highly sensitive persons are like standard batteries that actively drain while they are out in the sun. If an introvert wants to recharge, they cannot stay in the high stimulation environment.
No, they had to be taken out of the sun and plugged into the wall in a dark, quiet room.
That analogy maps perfectly onto the neurochemistry, doesn't it?
It really does. Because to recover from that dopamine overflow, introverts cannot rely on the sympathetic nervous system. They require the parasympathetic nervous system to take over, relying on a completely different neurotransmitter, acetylcholine.
Acetylcholine, how does that physically work to restore the nervous system as opposed to dopamine?
If dopamine is the highly activating chemical that drives you to seek external rewards and engage with the world, acetylcholine is the chemical of internal reward, restoration, and calm, reflective focus.
Okay.
It binds to muscarinic receptors to slow the heart rate, promote digestion, and enhance selective attention to internal thoughts rather than external stimuli.
But the crucial biological catch is that the acetylcholine pathway is only strongly activated when external sensory stimulation is extremely low.
You physically cannot access your restorative neurochemistry while you are still at the party.
You have to withdraw to a quiet, low-demand environment to trigger the acetylcholine release.
Exactly.
And if you force yourself to stay in the sun, if you keep pushing through the dopamine overflow,
You experience a total systemic crash. The nervous system becomes entirely dysregulated.
what does that look like?
The prolonged sympathetic arousal leads to intense irritability, physical exhaustion, brain fog, and severe anxiety. That is the biological reality of the introvert hangover. It is not a metaphor. It is a profound neurochemical deficit.
Which maps perfectly onto the behavior of our dreamer. They experience the rejection, panicked, and instead of withdrawing to let their acetylcholine system recover, they force themselves to run around the ship being incredibly loud and energetic,
They flooded their already overwhelmed system with dopamine they couldn't process.
forcing their nervous system far past its metabolic limits. The climax of the nightmare is simply the brain visualizing that total system crash.
Which brings us to the terrifying symbolism of the pursuers in the dark corridor.
Yeah, the dreamer is sliding down the water slide, desperately trying to escape a man in a suit selling drugs, and a doctor in a white coat trying to inject them with a yellow liquid. Why these specific figures? Why not a monster or a bear?
In the context of a nervous system driven to exhaustion by overadaptation, those figures are incredibly potent metaphors for external societal pressure, forced conformity, and the relentless demand to be normal.
They embody the expectations of a society that idealizes extroversion.
Think about the archetypes. A man in a sharp business suit and a doctor in a white coat represent ultimate authority, correctness, and the established rules of how you are supposed to behave in a highly structured capitalist society.
Right.
The drugs in the injection represent a forced external cure, an attempt to chemically or behaviorally modify the self.
The dream is articulating a deep-seated fear. Society demands that you swallow this pill, take this injection, modify your natural state so that you can fit in and function like everyone else.
And the dreamer is running for their life from that demand to conform, because conforming is what just caused their nervous system to crash.
This specific type of panic is heavily linked to a psychological profile, often seen alongside rejection-sensitive dysphoria, known as pathological demand avoidance, or PDA.
PDA, right.
Let's break down the mechanics of PDA, because it sounds like it goes far beyond just being stubborn.
It has nothing to do with stubbornness. In a state of PDA, the nervous system is so fundamentally overwhelmed and dysregulated that it perceives any demand, even a well-meaning request, a simple question, or a baseline societal expectation as a literal existential threat to its autonomy and survival.
Any demand at all.
Yes. And this reaction is mediated by a structure deep in the brainstem called the periaqueductal gray, or the PEG.
The PEG. That's incredibly ancient, evolutionary speaking, right?
Very ancient.
Yeah.
It interfaces directly with the amygdala to control our most primitive primal responses, fight, flight, or freeze, without requiring any input from the conscious logical cortex.
So it bypasses logic completely.
When PDA is triggered, the peg goes into absolute overdrive. It hijacks the brain. That is why the dreamer hurls themselves down a water slide.
Because the water slide is a classic psychological symbol of regression, a desperate attempt to slide away and escape pressure at any cost.
But no matter how far they slide, the suit and the doctor are always right behind them.
Because you can't outrun societal expectations. The external environment will always demand that you adapt. And if your internal resources are completely depleted, that everyday demand feels exactly like a predator hunting you down.
Exactly.
Which forces the dreamer to hide in the worst possible place. They pull themselves into a drawer only to realize it is a morgue, and they are surrounded by the dead bodies of the friends they were just celebrating with. What is the brain visualizing with this horrific imagery?
It is visualizing the absolute collapse of the social fabric. Sociologists like Peter Berger and Thomas Luckman wrote extensively about how human beings construct our social reality through shared agreements and interactions.
So in a symbolic sense, a morgue represents the ultimate collapse of that everyday social order.
It is the cold, sterile place where the rules of life, interaction, and relationship permanently end.
It is the absolute end of the line for connection.
Now, it is important to note that in traditional Japanese dream interpretation, death is frequently viewed as a positive symbol.
Oh, interesting.
Yeah, it can represent necessary rebirth, leaving the past behind, and transitioning to a new, healthier phase of life.
Similar to the death card in tarot, which usually signifies transformation rather than literal death.
Precisely. However, the neurobiological analysis argues that in this highly specific context, hiding in a dark morgue drawer after a terrifying pursuit caused by social rejection, it is not a symbol of rebirth.
It is a catastrophic emergency alarm.
Right. Drawing on the work of Jungian psychologist Marie-Louise von Franz and heavily supported by clinical trauma studies, specifically research observing Cambodian refugees suffering from severe PTSD. The presence of the dead friends symbolizes the total collapse of the attachment system itself.
The attachment system being our fundamental biological ability to trust, seek comfort in, and connect with other human beings.
Yes. When a trauma survivor or someone whose nervous system has been pushed past its absolute limit dreams of their loved ones dead or destroyed, it represents the ultimate existential terror.
The deep-seated, horrific belief that all social bonds will inevitably fail.
Is the internalization of the idea that connection is a dangerous illusion, and that ultimately you are entirely, permanently alone. The friends in the drawer aren't just dead bodies. They represent the death of the dreamer's ability to ever believe in safety and belonging again.
Wow. The brain is basically concluding, I tried so hard to belong. I completely exhausted my metabolic resources trying to perform for the group, and in the end, it was all fake. The connections were dead anyway.
It's the visualization of absolute burnout and despair.
And this sets the stage for the strangest, most clinically diagnostic detail in the entire dream. The severed hand. The dreamer is lying in the morgue drawer, and a dead person reaches out and violently tears their hand off at the wrist. But there is absolutely no physical pain. There is only pure, paralyzing terror.
The absence of pain is the key here.
Why is the pain missing? In a nightmare, the brain usually simulates the pain of the attack, doesn't it?
Well, applying clinical trauma theory, this exact experience, cognitive terror, entirely disconnected from physical sensation, is the textbook definition of dissociation and emotional numbing.
Dissociation. We hear that word a lot lately, but what is actually happening in the nervous system to cause it?
When a person experiences intense trauma or extreme, prolonged anxiety that they cannot escape, the nervous system first tries to handle it through sympathetic hyperarousal, the fight or flight response.
This is the adrenaline, the pounding heart, the sprinting down the water slide.
But if the threat doesn't stop and the person realizes they cannot escape, like being trapped in a morgue drawer, the nervous system recognizes that fight or flight is burning useless energy. It runs out of gas.
So what happens then?
When that happens, the system violently shifts into a state known as dorsal vagal shutdown.
Dorsal vagal shutdown. This is related to the vagus nerve, correct?
Yes. The vagus nerve is the primary component of the parasympathetic nervous system, but has two distinct branches. The newer, myelinated ventral branch handles social engagement and calm connection.
And the older branch.
The older, unmyelinated dorsal branch controls the primitive freeze or play dead response found in reptiles. When the nervous system crashes into dorsal vagal shutdown, your heart rate plummets, your body goes numb, and your consciousness essentially detaches from your physical form to protect you from the unbearable agony of what is happening.
The brain actively blocks the physical nociceptive pain signals from reaching your conscious awareness.
It flips the breaker on physical sensation to protect the mind from shattering.
But the horrifying part is that while the physical pain is blocked, the amygdala, the fear center, continues to record the sheer terror of the event.
So you experience the horror cognitively, but you are completely disconnected from your physical body. That is true dissociation.
The dream is literally simulating a dorsal vagal shutdown. The dreamer is experiencing the thought, I'm being torn apart, but I'm so overwhelmed and detached I can't even feel it.
And the specific choice of the hand being severed is highly symbolic in this context.
In psychological terms, the hand represents agency and control. Your hands are how you manipulate your environment, how you reach out to connect with others, how you build your life, and how you defend yourself.
So having your hand violently torn off symbolizes the total stripping of agency.
Exactly. The dreamer can no longer reach out. They can no longer connect or defend themselves. They are completely powerless. The relentless, forced adaptation to the social group has cost them their autonomy.
The severed hand without pain is the brain's ultimate desperate warning. You have adapted so much to please others that you have completely lost control of yourself, and you are so numb to your own needs that you don't even realize you are bleeding out.
That is incredibly heavy, but also profoundly clarifying. This isn't just a random bad dream, it's a biological intervention. The nervous system is throwing a massive red flag, screaming that the way the dreamer is navigating their social environment is literally destroying their internal architecture, which means we have to pivot to the solution.
We do.
If our waking lives, the way we overextend ourselves, the way we swallow micro-rejections, the way we constantly perform to maintain group harmony, if all of that is driving our sleeping brains to simulate being chased into a morgue and dismembered, how do we stop it?
The fascinating thing is that the solution is actually hidden right inside the dream itself.
Really? Where?
There was a heroic moment in the narrative, a moment of profound psychological health and self-preservation, even though the dreamer quickly abandoned it.
Wait, you mean the moment right after the cigarette rejection? Before the dreamer started running around making those fake, energetic goodbyes, their very first instinct was to loudly declare, I'm going home.
Yes. In clinical psychology, that declaration, I'm going home, is the establishment of an assertive boundary.
An assertive boundary.
The nervous system correctly registered that the environment was no longer safe, rewarding, or metabolically sustainable, and the immediate, healthy instinct was to remove the self from the toxic environment.
So the mistake wasn't wanting to leave.
No, the mistake was the subsequent performance, forcing the system back into sympathetic arousal to manage everyone else's feelings about them leaving.
They tried to manage the group's perception instead of just honoring their own biological limit.
Exactly.
Which brings up the ethics of self-care, particularly for introverts and highly sensitive persons. Elaine Aron, the pioneering psychologist who formalized the research on highly sensitive persons, speaks directly to this.
Aron's work is vital here because she addresses a pervasive misconception in our hypersocial culture. We are constantly fed the idea that walking away from a social event, declining an invitation, or needing to be alone is somehow selfish, antisocial, or weak.
We are taught that being a good friend or a team player means always being available and always pushing through your own discomfort for the sake of group cohesion.
It's the constant pressure of just stay for one more drink or don't be a party pooper.
But Aron points out that for highly sensitive people who process social data incredibly deeply and possess intense empathy, pushing through that discomfort is a dangerous fallacy.
HSPs are highly susceptible to a phenomenon known as emotional contagion.
Emotional contagion. It's like catching a cold, but you are catching other people's nervous system states via mirror neurons.
Precisely. They effortlessly and involuntarily absorb the stress, anxiety, and moods of the people around them. If an HSP is in a room with a tense couple, their own insula resonates, and they feel that tension in their own physical bodies.
Because of this high level of unconscious processing, their cognitive resources, the metabolic gas in their tank, burns at a significantly faster rate than someone who filters out that data.
The battery drains faster in the sun. And this leads to Aron's most powerful argument. For these individuals, setting boundaries is not an act of selfishness, it is a fundamental ethical duty.
It is an ethical duty to yourself and to the people you care about. If you constantly ignore your biological limits, if you allow yourself to completely run out of cognitive resources and push your nervous system into a chronic introvert hangover, you become irritable, exhausted, and resentful.
Your prefrontal cortex goes offline, meaning you lose your capacity for genuine empathy and emotional regulation. You become biologically incapable of actually helping anyone or being a supportive friend.
You can only interact with people from a place of deep burnout and masked anxiety. You essentially become a burden to the group because your nervous system is completely fried.
You aren't bringing your actual self to the relationship, you're bringing a survival mode projection.
So, stepping back, setting a hard boundary, and taking the time to recharge your acetylcholine isn't running away. It is the responsible, ethical action required to maintain your capacity to connect authentically.
You have to secure your own oxygen mask first, or you are useless to the person sitting next to you.
Exactly. So, translating this complex neurobiology into actionable advice for the listener, the first critical step is learning to metabolize micro-rejections in real time.
Yes. When you experience the real-life equivalent of being denied the cigarette, a colleague talks over you in a meeting, a friend makes a dismissive joke, a text goes unanswered, do not just swallow the discomfort and pretend you are fine.
When the DACC alarm goes off, don't just put on a smile and shove the feeling down into the amygdala. Because if you swallow it, the nervous system stores that unprocessed data and it compounds.
It builds up a metabolic debt until your system crashes into a massive threat simulation while you sleep. You have to process the emotion using your higher cortical functions.
The key is prefrontal regulation. Acknowledge the pain. You don't necessarily have to start a conflict in the middle of the meeting, but internally or later in a private space, you must validate your own biological experience.
Say to yourself, that interaction hurt. My brain registered that as an exclusion. Write it down in a journal.
By giving the feeling a specific name and acknowledging its reality, you force the prefrontal cortex to process the event, effectively taking the raw, terrifying data out of the primitive fear centers and neutralizing it with logic and context.
And the second piece of actionable advice is to ruthlessly trust your internal somatic gauge.
When you are at a party, a networking event, or a family gathering, and you feel that sudden, visceral drop in energy, that distinct moment where you realize you are no longer participating, but simply performing to maintain the illusion of belonging, listen to that signal immediately.
That is your nervous system telling you that your metabolic resources are depleted. Say, I'm going home, and actually just go home. Do not do the grand tour of fake high-energy goodbyes.
Do not burn your last reserves of energy trying to manage everyone else's perception of your exit. Gracefully and assertively remove yourself from the environment. Recognize that stepping back is a healthy, protective, biological choice to reclaim your true agency before it gets severed in a nightmare.
This has been an absolutely incredible journey.
It really has. We started with a weird, unsettling dream about a cruise ship and a denied cigarette. And from that single narrative, we unpacked the evolutionary biology of how our brains switch from social simulation to threat simulation just to keep us alive.
We looked at the literal neurobiological reality of social pain and how chronic loneliness degrades the body with the same ferocity as smoking 15 cigarettes a day.
We explore the mechanics of the introvert hangover, the danger of dopamine overload, and why the pressure to conform triggers ancient survival circuits in the periaqueductal gray.
And ultimately, we learned that setting boundaries isn't a luxury. It is the vital ethical duty we owe to our own nervous systems.
It is a remarkable synthesis of neurobiology, evolutionary psychology, and trauma theory. And to the listener, if you ever wake up from a dream like this, heart-pounding, terrified of an invisible pursuer, feeling deeply existentially alone, I hope this deep dive helps fundamentally reframe that experience for you.
You shouldn't view that nightmare as a weakness, a flaw, or a sign that you were broken. You should view it as your highly intelligent, fiercely protective nervous system doing exactly what it evolved to do, sounding a necessary alarm to save you from the slow, quiet, physiological damage of over-adaptation.
Your brain is being your own best advocate, demanding that you protect yourself. I want to leave you with a final thought to mull over as you go about your day. We spend so much time analyzing our dreams to try and understand our waking lives, but considering how intensely and how literally our neurobiology simulates social exclusion as physical death,
Wait.
Well, how much of your everyday waking behavior, the jokes you force a laugh at, the invitations you accept when you are already exhausted, the true opinions you swallow to avoid rocking the boat, how much of that is actually just a subconscious attempt to keep your brain's threat simulation alarm from going off? Are you authentically living your life, or are you just desperately trying to outrun the man in the suit? Thank you for taking this deep dive with us. We'll catch you next time.